Today we're going to evaluate the 5-volt power supply I bought off Amazon from, I'm not even going to try to pronounce that, but there you go there. And in the box, it's a rather nice box. Yeah, it's a rather nice box. I was actually pleasantly surprised. But it is a bit overkill. But it came with a little note to their customer. Also, this wasn't in the description. But it came with this USB light, and we'll give it a quick test. And indeed lights up. So yeah, that's interesting. Put that out of the way here. And this is what we're really after here: a 5-volt, 2-amp power supply. I'm mainly interested today in the voltage. I just want to make sure it's within the specs for the device that I have, which will accept anything from 5 to 5.5. Basically, TCL logic type power supplies. Got a coaxial connector. So to check this out, I'm going to actually use an oscilloscope rather than a volt. Alright, so we're going to plug the power supply in. And we're going to take our coaxial plug, clip our alligator clip on the outside, put our probe in the center, and see, get a good grip here. There we go. There we go. We got a firm connection now. All that previous stuff was just noise from a bad connection. We've got a solid connection now. Our voltage is 5.39 to 5.43. That's within the acceptable range. This is, of course, unloaded. It'll actually drop down just a little bit once I have a load on it. There's hardly any ripple that's visible. We'll change our coupling to DC. I'm sorry, to AC. And we'll see if we can see some noise. Well, that's hardly anything to be worried about. And that may actually be the noise from the probes or how I'm holding it. Yeah, you can see that there's very little change with it connected and not connected. So that is mostly background noise at 200 millivolts per division. So that's very, very small bit of noise. And that's actually with the probe grounded, just give you an idea of the background noise. So, yeah, I'm not worried about any AC ripple on the power supply. It's good. Alright. So, change our coupling back to DC. And we'll put the scope away. Alright. There we go. Away. Let's next take a quick look in the power supply. Because this one actually has a screw. I've actually in the past bought power supplies I was where kind of, well, I'd just say they were too cheap to be good power supplies. I have cracked them open to take a look inside to see how things were, shall we say. And actually, I should actually make a note of those as well, and do a video for them, because they were spot on. They were good power supplies. I actually wish I had bought more of them when I had the opportunity. But in order to determine that, I had to sacrifice one, because it did not have a screw like this one. You can see there's a pair of terminals that go into a socket of sorts. And we're going to slide this guy out. There you go. Kind of neat. But you can see the main filter capacitor, input bridge. Oh, an inductor. Nice. So we have a line choke. Resistor being used for a fuse. Yeah, I've just had to learn to live with that. It does the job though. We got our little switch mode chip there. Let's see, I'm not sure if we can make that out or not. Well, no matter. It's probably one of the standard switch mode chips. The capacitor for the switch mode chip's power supply, and no doubt a pull-up resistor, kind of kick things off. Anyway, notice there's a nice gap cut in the board there for creepage, although it's not directly underneath the transformer, but it is underneath the components here at the very end. So that's interesting. But there's a good healthy gap between the line powered and the low voltage side. We've got our required little blue cap. Let's see if he's got his he's the right color, but I don't see all the little symbols you normally have on the self-healing capacitor that is traditionally used to work as a noise filter between the high and low side, or the couple of low and high side. We got a opto isolator for feedback, and R6. Let's see what we got here. TL, I believe that's a transistor. Another time we'll explore more detail what's a switching power supply. That's a pretty healthy diode. That's about the size of a 3 amp diode. So that's good. So I can probably get 2 amps without any worries. But yeah, we would normally like to see a higher current diode, but in a cheap little power supply like this, got 3 amps and ready for 2. I'm not gonna knock that. So that looks good. So I'll put this back together. So there you have it. Quick look inside. Power supply. Get this guy back together because I actually do want to use it. Oh, I put it together wrong. So notice that. Should line it up with that. And there's our slot. Alright. Almost. Still don't have it quite right. There we go. That's perfect. And I got a little slot on the board. Decent strain relief. I will be replacing the coaxial plug. I've already thoroughly voided the warranty anyway, so no worries. I'm not going to worry about any warranties. I think this, from what I see inside, this is going to do just fine. We'll take a look at some other wall warts later. There are some that I'm going to do repair videos on. And yeah, you can make a decent argument to that just to replace them. Yeah, I mean, the economics of repairing it versus replacing, it's, yeah. But It's kind of fun though to see how things are made, for the for good or bad or indifferent. All right, back together. Put the screw in. We have to play back the video to find the screw. Alright. 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 Screws back in. Power supply is. Let's plug it in, make sure it still works. Alright, no buzz pop, always a good sign. Let's see. Oh. And we are going to hit measure. Alright. Yeah. Still measuring really good. We're still measuring at just a little hair under 5.5 volts. Good. Good. Get a decent thumbs up helps a lot.